Welcome to this video about the Turbimax CUS52D. I am Katrin Hartlieb, Product Specialist for Turbidity, and in this video I will show you how easy the maintenance of the CUS52D is. The CUS52D is a smart MemoSense sensor, which allows accurate turbidity measurement, especially in the low measuring range. Since the sensor is available in both stainless steel and plastic, it can be used in drinking water production and in many other applications with fresh, processed or salt water. The maintenance of the sensor is easy and requires little effort. There are no wear parts to be replaced, and thanks to the sensor's continuous electronic control of the measurement components, the measurement is as good as drift-free. Therefore, regular calibration or adjustments are not necessary. In other words, the sensor just needs to be kept clean. However, for reliable measurement, cleaning plays a very important role and must not be neglected. Therefore, I will show you in this video the different cleaning possibilities and how to apply them. The sensor head contains the measuring components and is angled by 45 degrees. This has the advantage that the sensor can be installed straight into the process and the flow automatically cleans the sensor head to a certain degree. This self-cleaning effect works best when the sensor is directed against the flow. If, however, the measured values become unstable or start to drift, as in this example, it is time to actively clean the sensor. This can be done manually or automatically. For manual cleaning, you simply need a soft sponge or lint-free cloth and clear water or a cleaning solution. Although the sensor is robust due to the materials used, do not use sharp-edged objects like sandpaper for cleaning in order to avoid damages. And of course, please also wear your personal safety equipment and gloves. Before you take out the sensor for manual cleaning, set the sensor outputs in the Liquiline on hold, so that the measurement output is not affected by the cleaning. For that, go to Menu, Setup, Inputs, and select your sensor channel. Scroll down to Manual Hold and set it to On. Now take the sensor out of the process. Be careful not to twist the sensor cable while doing so. If an immersion assembly is used, remove the protection cap first before you take out the sensor. Ideally, the sensor already has a quick fastener for easy removal. Now clean the sensor with a soft sponge or lint-free cloth and water. If there are stubborn buildups, first submerge the sensor in a suitable cleaning solution. For example, a 1 to 5% hydrochloric acid solution for lime buildups. As mentioned before, the sensor is robust, but in order to minimize unnecessary chemical stress, clean the sensor with chemicals as short as possible and as long as necessary. Afterwards, rinse the sensor thoroughly with water to remove possible streaks and chemical residues at the measurement components. Now reinstall the sensor into the process. And release the hold on the outputs again. To minimize your effort for manual cleaning and to prevent deposits or the accumulation of air bubbles, we recommend to use an automatically controlled cleaning unit. Basically, there are two different options: compressed air or ultrasonic. The cleaning power of compressed air is more effective. However, the advantage of ultrasonic cleaning is that the cleaning unit does not come into contact with the process medium and can therefore be used in hygienic applications. I will now explain these two cleaning methods. For cleaning with air, you need the compressed air cleaning nozzle and, of course, compressed air. For installations in immersion assemblies, there is the compressed air cleaning system. This unit is mounted on the sensor head. The sensor has laser markings on the back of the sensor head, which indicate the correct orientation for best possible cleaning and at the same time simplify the installation, which I will show you now. At first, fit the compressed air cleaning system on the sensor. Wet the sensor head in order to simplify the installation. Then position the securing ring for the compressed air cleaning system between these two installation marks. Use an Allen key to tighten the securing screw of the compressed air cleaning system slightly so that the unit can still be rotated. Turn it until the slit on the black ring is on this vertical installation mark. In this way, the nozzle is offset by 20 degrees when blowing air at the optical windows. Then tighten the securing screw and fit your compressed air hose on the 8 mm hose adapter, or if you have a 6 mm hose, remove the adapter and connect it directly to the 6 mm hose barb. To control the compressed air supply, use a simple pneumatic two-way valve with a maximum pressure of 2 bar. That's it. Some of our flow assemblies have a cleaning connection already integrated, such as the CYA251, to which compressed air hoses with a diameter of 6 mm can be connected. For flow assemblies and pipes without the possibility of compressed air connection, there is the CYR52 ultrasonic cleaning system. The CYR52 generates cavitation in the process medium by ultrasonic waves, which dissolves dirt and air bubbles on the sensor before they are removed by the flow. To see how the cleaning unit is installed, please watch our video Commissioning of the CYR52 ultrasonic cleaning system. Regardless of which cleaning method is chosen, all of them can be controlled via the Liquiline. Your Liquiline device just needs a free relay at which the pneumatic control valve or the CYR52 generator can be connected. Use only terminals of an additional module in the Liquiline. Do not use the alarm relay of the base module. The Liquiline offers the possibility to define a cleaning program and to determine the cleaning intervals and times according to your needs. If no empirical values are available, we recommend starting with an interval of 10 minutes and a time of 10 seconds for compressed air cleaning and adjusting if necessary. If you use the CYR52, please do not fall below the minimum interval of 5 minutes and do not exceed the maximum cleaning time of 5 seconds in order to avoid overheating of the ultrasonic transducer. Finally, check if all the connections and the sensor are installed correctly. Also make sure that the sensor is immersed into the medium before you start the cleaning program. And this brings me to the end of this video. Thanks for watching. I hope you have enjoyed the video, and if you find it helpful, like it.